Experts suspect that there are more than a quadrillion exoplanets in our Milky Way alone, about 1/5 of which resemble Earth. In addition to these planets, there are probably another quadrillion rocky moons that are similar in structure to our home. So how likely is it that we are not alone in this universe? Recently, the alien alarm already rang when researchers spotted a planet right in our closest cosmic neighborhood that looks confusingly similar to Earth. The key to all the questions that have been haunting researchers' minds ever since is the new James Webb telescope. Join us as we bring to light what startling discovery James Webb made on Proxima b. The exoplanet Proxima b. Exoplanets are all those planets that are outside our own solar system. It doesn't matter if they are in our neighboring star system, Proxima Centauri, or in a galaxy billions of light years away. It wasn't that long ago that we humans were first able to discover exoplanets. You have to imagine that these celestial bodies are tiny compared to the cosmic dimensions and do not emit their own light. So, it's not so easy to detect them in the distance, and only two methods are suitable. The transit method observes the light spectrum of stars and registers tiny obscurations that periodically appear in front of the star. These obscurations can be exoplanets, but also other celestial bodies, or phenomena like gas and dust clouds. The second method measures the gravitational field of the star itself. The orbits of the planets change the position of the star in space very slightly. Thanks to the finest measurement methods, such changes can be registered and give scientists conclusions about exoplanets in the vicinity of the star. Rather rarely, exoplanets are discovered directly or by pure chance. All in all, it's still a challenge to perceive and study planets outside our solar system. The new James Webb Space Telescope is expected to make the search for new worlds in the cosmos much easier. The most expensive and best telescope of all time is equipped for the first time with such fine measuring sensors that exoplanets can be studied more precisely than ever before. A new era in planetary research. Proxima b was discovered back in 2016, when telescopes were still at work that were barely capable of spotting the planets. That in itself represented a significant advance in the astronomical development, but with the discoveries of the planets, questions arose that the old telescopes could not answer. What do these planets really look like? Do they resemble Earth? And if so, how many and which of them might be inhabited? James Webb's main tasks, in addition to analyzing distant planets, are to study the Big Bang and ultimately to conduct extended explorations of the planets in our own solar system. Placed deep in space, this telescope looks sharper and farther than any before it. One of the main features of this telescope is that it simply looks through cosmic dust clouds, increasing the range by several million light years compared to Hubble. These wonders are made possible by 16 giant honeycomb mirrors. These gold-coated mirrors can reflect the finest infrared rays, providing a picture of space far beyond our previous powers of imagination. Spectrometers and color analysis filter the light spectrum around exoplanets. In this way, the elements and aspects, such as the presence of an atmosphere around exoplanets, became visible for the first time. Spectrometers make detailed analyses of the light waves. Each exoplanet reflects light from its star in a unique way. When the light hits the planet's surface and atmosphere, it is reflected by matter, gases, dust, or minute water particles, and bounced back into space. Contact with the elements causes the light rays to change in such typical ways that the light waves reflected from water, oxygen, or methane are the same everywhere in the cosmos. Webb's technology can detect these subtle differences across billions of light years, giving us a spectrometer image of the entire planet. Other data that scientists can discern from the patterns of light rays include quantities such as a planet's density or mass. Even the size of a distant exoplanet can be calculated fairly accurately. Most important in the search for life in space, biomarkers include water and carbon compounds. Oxygen is probably another condition for the emergence of life. We don't know this for sure yet, because it's quite conceivable that life forms exist in the cosmos that originated under conditions quite different from ours, perhaps breathing a different gas, or getting by without any light or major water resources at all? We don't know yet, and despite this enormous progress, the exploration of exoworlds is still in its infancy. What did James Webb find out about Proxima b? Proxima b, one of the closest exoplanets to Earth. It is only 4.24 light-years from Earth and orbits the star Proxima Centauri. Together with Alpha Centauri A and B, it is part of the trinary star Proxima Centauri. Even older telescopes could determine with their capabilities that Proxima b is located in the habitable zone of its star. In the habitable zone, the planet is close enough to its star to get enough heat for complex life to form. At the same time, planets in the habitable zones are also far enough away from their planet star to avoid being burned by it or bombarded with too much radiation. Determining the habitable zone of a star system is another challenge for astronomers, because what falls under habitable looks different in every star system. Depending on the luminosity and size of the star, the section where life can form is at very different distances. Between Proxima b and its star is a distance of only 7.4 million kilometers, while our Sun is about 149.6 million kilometers from Earth. That's 5% of the distance from our Sun. Nevertheless, scientists think Proxima b is habitable because the star Proxima Centauri is 4,000 times fainter than our Sun. In addition to the habitable zone, Earth resemblance plays another major role in the search for potentially habitable exoworlds. Proxima b is 1.27 times the size of Earth. Scientists also believe that Proxima b hosts water on its surface and that there is terrestrial terrain such as mountains. Despite the similarities, there are also some major differences. For instance, Proxima b completes a daily cycle in 11 Earth days. To do this, Proxima b orbits its star in a bound orbit. In other words, one side of Proxima b receives light forever, while the other side is completely dark. The motion is similar to the Earth's moon. Proxima b sends a signal directly to Earth. The SETI Search for Extraterrestrial Intelligence project managed to record a strange signal in April and May 2019 that appeared to be coming directly from Proxima b to us. To be precise, it was a radio signal on a frequency of 982 megahertz and a strangely technical sound. On Earth, this frequency is in a range not normally generated by man-made satellites and spacecraft, but the repetition frequencies and patterns resembled nothing researchers had previously received from space. Intensive research was conducted for weeks to determine the origin of the signal, and some enthusiastic researchers were already reporting a technosignature emanating directly from Proxima b. In the course of further research, however, disillusionment set in. The signal, which was already celebrated as a breakthrough by SETI, could not pass the tests of other scientists, and finally researchers came to the conclusion that the signal did not even originate from space, but had been generated by a terrestrial interference source. Nevertheless, the signal has not been clearly explained until today. Since it was heard only once for about 30 hours and never again afterwards, no further investigations could be carried out. However, the uniqueness of the occurrence reinforces the assumption that the signal was a one-time event in the cosmos, or a glitch in the recording of the data. If it were a technosignature emanating from an alien civilization, the signal would certainly have been heard much more often. Nevertheless, researchers are not giving up on closely examining Proxima b for the existence of life. Artificial light as evidence of extraterrestrial life. To find out if this planet, or any other in the vastness of space, harbors advanced life, researchers from Harvard University in the US have come up with something new. Artificial light must emanate from a higher civilization, says Avi Loeb, the study's leader. The scientist and his team specialize in detecting artificial light around exoplanets. To that end, the researchers considered how to configure the James Webb Telescope to detect artificial light from both the dark and bright sides of Proxima b and other planets. However, during initial measurements, disillusionment came again. Namely, the results showed that the bright side of Proxima b emits an intense amount of UV radiation and X-rays, but no traces of light bulbs from extraterrestrial life forms. The high levels of radiation already make it much less likely that life exists there. Of course, we can't rule out the possibility that there are living beings on the dark side of the planet, though experts think that's unlikely. With nanospaceships to Proxima, breakthrough starship. Actually, SETI, the organization that searches for extraterrestrial intelligence, has been doing nothing but listening into space for decades. Red dwarf stars are considered the most likely types of stars to allow life in their vicinity. Radio telescopes such as the Allen Telescope and the Parkes Telescope in Australia are therefore constantly focused on these types of stars. Thanks to the funding from a multi-billionaire, SETI will soon launch a very different project. The Breakthrough Starship program envisions sending nanoprobes to our nearest planetary neighbors to study them in detail on the spot. Breakthrough starships will be only the size of matchboxes. Thanks to high-speed lasers, the mini spacecraft will reach about 20% the speed of light and travel the distance that would take us humans thousands of years to cover in about 200 years. Equipped with miniature cameras, the nanoprobes will then illuminate the situation directly on site. In a few hundred years, we could then finally know for sure whether there is life on Proxima b or not. So, we won't be able to see these results. Do you still find the project exciting? Or do you think we need to find better technologies to make contact with potential other life forms in space?